should Mallu, sir. Okay. Okay, we'll start the lesson. Okay. So yesterday we have discussed about the metal removal rate, and just we'll try to revise whatever we have discussed yesterday, and time, and we have also seen that it is a formula we have derived also. Di is the initial diameter of workpiece, D is the depth of cut, F is the feed, mm per revolution, N is the RPM of job, and V is the cutting speed. Already you know. So that what is the volume metal removed per revolution? Metal removed per revolution is volume of chip having length pi d. Pi d, volume into cross sectional area. Length is pi d, and cross sectional area is d into f. That is the depth of cut into feed. So hence volume of metal removed per revolution will be so pi di into d into f. Volume is in mm cube. So what is the metal removal rate? Metal removal rate will be defined in terms of this volume of metal removed per revolution means E into product of N. So metal removal rate is MRR is equal to pi di into d into f into N. So whenever you are adding that capital N, that is revolutions per minute, it will be mm cube per minute. So metal removal rate is expressed in mm cube per minute. So we have that particular formula also, that in terms of cutting speed, we can express the metal removal rate as 1000 into volume into depth of cut into f. That is 1000 into V into D into F. So what is V here? It is nothing but pi dn by 1000 or di. What is di here? Already we have seen. It is the initial diameter of the workpiece. So that is the volume metal removal rate we have seen. So we'll try to do some problems based on this after finishing of the machining time or turning time. Okay. So what is L? This also we have discussed yesterday. We will revise. So L is total distance traveled by tool in feed direction in a single cut, because you cannot remove the material. Hello, Hajad, have you joined?
Sir.
Master garu unnara?
Sir.
Srinivas garu unnara?
Yes, sir.
You mute chestunna ma because disturbance undi.
Okay, sir.
L is equal to total distance.
Sir. Co-host చేయండి సార్ నన్ను, నేను చేసేస్తా.
కోహోస్ట్ అంటే మాస్టర్ గారు జాయిన్ అయ్యలేదు తెలియదు. కోహోస్ట్ మళ్ళీ
ఎవరు జాయిన్ అవ్వలేదు సార్.
స్టాప్ చేయాలి, స్క్రీన్ స్టాప్ చేసి అక్కడికి వెళ్ళాలి. నాకు అర్థం కావట్లేదు కంట్రోల్స్.
చాలా మంది మ్యూట్ చేశాను.
సో నేను మ్యూట్ చేసి వస్తున్నాను అందరినీ. ఓకే
ఓకే సార్.
ఓకే. So this is a permanent disturbance. People are not understanding the seriousness of the class. So L is equal to length of surface to be machined. So what is capital L? Total distance traveled by the tool in the feed direction towards the job or the workpiece. So what is L1? I should have shown you in the diagram also. Tool approach just before machining has been started, or the tool position. So that you have to position the tool. As far as CNC, it is given by that G00. Capital letters you have to use, and you have to see that that L2 is over travel of tool, because after machining you have to go for all travel of tool, because it will be the particular tool will be digging into the workpiece. during machining also, you have to go for all over travel of the tool and again start for the next pass, because the material cannot be removed in a single pass. That is D is the depth of cut, F is speed, mm per revolution, N is spindle, the particular rotational speed, spindle or job rotational speed, because job will be attached to the three-jaw chuck or held in the three-jaw chuck, and it is a part of the spindle. Any audio problem? Because we are going with the mobile data, bear with us. We have no Wi-Fi today. So NP is the number of cuts taken during machining. Number of cuts taken during machining. So here already we have discussed DI is the initial diameter of workpiece in mm, and DF is the final diameter of the workpiece. Okay. So just try to see this particular whatever L1. L1 is nothing but is a tool approach, and L is equal to L plus L1 plus L2. So what is L2 here? Over travel of tool. So after machining has been over, it will go for a certain distance and then come again back for going for machining of the second pass. Because you cannot achieve the final workpiece dimensions, the job dimensions in a single pass. So that is the thing. This is the mandrel. It will be rotating, and the particular spindle will be rotating in anti-clockwise direction. And we have the driving plate and the dog. These are the lathe accessories, and the feed, the tool. The feed will be in the longitudinal direction towards the job. This is how you have to calculate the machining time in turning. So capital L is equal to small l plus L1 plus L2. So what is distance L? It is distance traveled by the tool and feed direction in single cut. That's why I'm coming again. I'm saying it is a single cut or a single pass. So capital L is equal to small l plus L1 plus L2. So in case of single point tools, this L1 and L2 are not there, because these are negligible and we have to neglect them. Only it is in case of a multi-point cutting tool that capital L is equal to L plus L1 plus L2 is valid. So all these are the things we have to get into your mind. And machining time. What is machining time? Machining time is designated by the term TM. TM is equal to capital L by F into N per cut or per pass of tool. What is capital L? We have seen distance traveled by the tool in the feed direction. So all these are the things we have to discuss, and N is the spindle speed in RPM. So next we have to discuss the cutting speed. Already we have seen V is equal to pi di into N by 1000, or N is equal to 1000 into V by pi di. So you have to rearrange the terms for the capital N. So cutting speed formula you have to remember, it is in meters per minute. So don't try to buy hard things. You have to practice the derivations, practice the problems, because we are doing number of problems. Last year we have unit 1 we have done, only practice those problems. So at the last we'll try to do 2 problems which are given in the previous question papers. Some sample problems are there and the examples also, and yeah, only you try to show what are the problems that we can have in this particular unit as far as the lathe machines are concerned. So machining time per cut is, what is machining time per cut? L by F into N. So L instead of N, you try to substitute the value of N in the denominator. You will be getting that 1000 V by pi di. You substitute that value in N. So you'll be getting that formula. Machining time per cut is, this denominator term will go to the numerator. It is pi di into L by 1000 into V into F. But what is the total machining time? This is only the machining time per cut, TM. But what is the total machining time? Total machining time is a product of machining time per cut into NP. What is NP? Number of cuts per passes. So you have to calculate that machining allowance. So machining allowance is the difference of the initial diameter minus final diameter by 2. So what is the material removed per cut? Material removed per cut is nothing but the depth of cut. The depth of cut T. And what is the number of cuts? NP, it is given as the ratio of total, it is given as the ratio of total machining allowance for material removal per cut. So what is total machining allowance? Total machining allowance is given by di minus df by 2, the initial diameter minus final diameter by 2. So by what is material removal per cut? It is depth of cut d, depth of cut. So whatever depth of cut you are giving the value for that particular machining operation, for that particular operation on lathe, you have to take that value into consideration. So all these are very important things you have to see. So the total machining time is Tm into Np. So you have to, so you know what is Tm. Tm is pi di into L by 1000 Vf into Np. What is Np? Di minus df by 2 by d. Small d. Small d is the depth of cut. Capital D and capital D are using for the initial diameter of the job di, and for the finished diameter of the job you are using df. So all these things you have to keep in mind. So you practice this derivations, which are very important, because you cannot say what is giving in the final exam, and you practice the problems related to this one. So what is the power required in turning? So power required in turning also we have discussed in the unit 1. It depends upon the cutting speed V, depth of cut D, feed rate F, and it also depends on the hardness and machinability of the metal. Because what is the hardness of the workpiece metal? Depends upon the higher hardness, more amount of power is required at the spindle, and power, we'll just try to see what is that. And what is the power required? Power required depends upon the cutting force, Ft. What is Ft? We have discussed in the previous unit. Ft is the tangential force, that is in the horizontal component, and Ff is the vertical component, that is the feed force. So you have to take, but here only the cutting force you have to take into consideration, the horizontal force, and it is given as a product of small k into d into f. So this k is a constant. So you just we have a tabular form in the unit 1. It depends upon the workpiece material. So what is the workpiece material you are considering? That value you have to substitute in the cutting force Ft, and d you know depth of cut, and f you know feed. You will be getting the cutting force Ft. Cutting force Ft. So power is a product of Ft into V. Ft, the cutting force, into the cutting speed V. So what is Ft? Small k into d into f. Small k is a constant depending upon the workpiece material, and d is the depth of cut, f is the feed, and v is the cutting speed. Is given by pi di n by 1000. So you have to remember the formulas, because without you are substituting the wrong formulas or the wrong values, just try to, that's why you have to, after the problem, you have to write conventionally, you have to write what is the given data. So in some of the objective type like GATE or IES, all you'll be giving irrelevant data, you people will be confused. So whatever the data that is required for your problem only you consider. So that is very important, and we'll try to come to the numerical problems now. So what is asking, some small problems are there. Don't worry, is asking in the short answers to 2 marks or 3 marks. So what is the cutting speed in turning a job having a diameter of 100 mm, and spindle speed is given by n, capital N, speed in RPM, 100 RPM. This is a simple substitution. Don't think we are doing small problems, but so many people will try to forget that formula because maybe in the confusion or you are relaxing as far as this subject is concerned. So pi value is 3.14, diameter of the job is 100, and the spindle speed is 100 by 1000. So simply you are getting that 31.4 meters per minute. So we'll come, slowly we'll try to increase the level of the problems. So next problem. So what is the next problem? A hollow workpiece a hollow workpiece of 50 mm diameter and 200 mm long is to be turned overall all over in 4 passes. He has given here 4 passes, not a single pass. The final dimension is achieved. So he has asked, so he has given the approach length. Approach length is given by L1. L1 is 20 mm. So what is over travel? Over travel is 10 mm. Over travel is L2. So what is speed? Speed is given by 0.8 mm per revolution. And cutting speed he has given as 30 meters per minute. He has asked us to calculate the machining time. So what is the machining time? Machining time, overall machining time is given by the product of Tm into the NP, number of passes per cut. So we'll just try to see this problem. We'll attempt this problem. So all of you, I don't have to say, you try to be careful in writing these problems. And because I'll be sharing the PPT or the PDF immediately after the class, the CRs are also sharing. And I hope the A section CR Sarah is also sharing with you. So 5 dn by 1000. So 5 dn by 1000. You just try to substitute the values, and you'll be getting the what is V here. Just try to find out R. So V is 30 meters per minute, and you have got that pi d hollow workpiece, the 50 mm diameter. 50 mm diameter. Pi is the pi is 3.14 into 50 into n by this one. So actually, yes, directly they calculated that value, or you try to simply substitute the values conventionally from the fundamentals. Pi 3.14 or 22 by 7 into d. The workpiece diameter is d 50, and n is you have to calculate the n value here. So n value you will be getting in RPM. That is the spindle speed or the job speed that is revolving along with the spindle in RPM. So that is 190.8. You don't try to just see this second and third steps. You simply substitute the values of whatever he has given. The cutting speed he has given, the diameter of the job he has given, the hollow workpiece is given, and you have to calculate n. So after calculating n, what you have to do? You have to calculate L, capital L. What I told you, capital L. Capital L is nothing but the total distance traveled by the tool in single pass, not for 4 passes. So first you have to travel for a single pass. So what is small L? It is 200. 200. What is L1? It is 20. What is L2? It is 10. He has given the data in the problem. So overall it is 230, but you have to calculate the length traveled by the tool in 4 passes. So length traveled by tool in 4 passes, suppose you try to take that as L1, it is 230 into 4. It will be 920 mm. So you have to be careful while considering the number of passes, and because this problem is related to not a single point cutting tool, multi-point cutting tool, you have to consider the values of L1 and L2 also. L1 and L2 also. So that is the problem you have to consider. And manufacturing time or the machining time, simply we have given that as L1 by Fn. So you substitute the value of F is speed, mm per revolution. He has given in the problem the data 0.8 mm per revolution, and we have found out now. And what is L1? 230 into 4. The length traveled by the tool in 4 passes. So that is the simple problem. Simple problem. So you have to take the number of passes. So instead of taking and yes, considered the total distance traveled by the tool in 4 passes, and simply substituted. He has asked the machining time. So the manufacturing time T, it will be it is 6 minutes, because time is given in minutes. So you just try to observe the things. So this is a simple problem, but you have to be careful. You don't worry about the marks. If you know the procedure, depending upon the procedure, the lengthier problem, you may be asking for 5 or 6 marks, and the B bit, if it is more explanation is required for the theory, it may be for 8 or 9 marks. So don't worry about the marks. If you know the concept, if you know the concept, then it will be easy. So just try to see this. This is also a simple problem, but here people try to commit mistakes. So here he has given only the, he has asked the machining time to face a job of 60 diameter. Some people may be worried he has not given length, but here you try to take the length as half of the diameter of the job. So it is 60 by 2, that is 30, and simply substitute the values he has given in the problem. So these are the problems that may be useful for objective type also, because he has asked here, what he has asked, what is the operation in this particular lathe machine as far as the problem is concerned. He has asked the machining time to face a job, of 60 diameter. So here the length is not given, so capital L. So here you have to take the half of the diameter of the job. So simply you have to substitute the value of the cross feed, because cross feed is for facing, you have to go for the cross feed. The particular units are same, the per revolution, and the capital N is the spindle speed in RPM, AT as given. So next problem we'll try to go. So all these are very important things. So if you are having any doubt, we'll try to again come back to this, because another two problems are there from the particular sets previously. Maybe the different sets are there, we cannot specify, but we'll try to do those problems related to the taper turning and the particular cutting of the screw threads, how to calculate the gear ratio, for the particular driver and driven. So that also we'll try to see. So now slowly we'll try to go to the another problem. So just try to read this problem. A rod 150 long and having a diameter of 15 So it is reduced to 14 So what is the initial diameter here? 15 The final diameter is 14 diameter in one pass of turning. Yes, asked in one pass of turning only we have got that particular diameter. So what is the natural? Sorry, he has given the wrong. Okay, spelling mistake may be there. Find the metal removal rate and machining time when the spindle speed is 400 rpm, capital N is 400 rpm, and feed is 200 per minute. So just try to see this problem. So you have to again write the given data, because there's an advantage every time, because directly some of the people are trying to take the wrong data from the already given problem. So already I told you di is the initial diameter of the rod and df is the final diameter of the rod. Ne has given 400 rpm, fe has given 200 per minute. So what is feed rate here? He has given only feed rate, mind you. So you have to calculate the feed rate f. So feed rate is per revolution. So you have to convert that per minute, that is feed. 200 by, what is the 200 by 400? So it is half, that is 0.5 per revolution. So what is the depth of cut? Already I told you, depth of cut is given by di minus df by 2. Di minus df by 2, or that simply you have to take that, you have to calculate the feed rate and depth of cut before proceeding with the problem. So that is 0.5 So here MRR already we have given the problem here. Metal removal rate, the formula is there previously. So pi di, what is di? It is 15. Don't take df. If you are taking df, the metal removal rate you will be having a problem. So because in the formula it is pi di into f is 0.5 into d is given as depth of cut, that is 0.5 again, and n. So n is directly given as 400 rpm, but sometimes you have to calculate n value depending upon the formula. So MRR is 4170. So what is metal removal rate? It is given in terms of volume. What is volume here? Volume cube per minute. So it is nothing but it is expressed as P is 0.5 in the denominator, capital L by F into N. So that 150 by 0.5 into 400. It is simply 0.75 minutes. So these are the random data as given. It's not that you can say how you can machine it 0.75, because it is only the particular it may be a single point tool. So single point cutting tool, because here we are not considered L1 and L2. You can easily recognize that the tool is a single point cutting tool from the given data that is given in the problem. So suppose it is giving over travel and other things L1 and L2, it will be the multi-point cutting tool. So you have to recognize what type of problem he is giving, what are the formulas you have to apply to that one. Because for a multi-point cutting tool, the number of passes, the final diameter of the job cannot be obtained in a single pass. So that you have to just observe or just think over. So that is a very important one. And next problem, he has given what is the calculate the time required to machine a job 170 mm long. So L is 170, 50 mm diameter, initial diameter is 50 diameter, to 165 mm length. He has reduced the length from 170 to 165. So try to observe this, somewhat a different problem here. And 40 mm diameter. The diameter of the job is 40 mm, and the spindle speed when job rotates at 400 rpm. So and capital N is 400 rpm. Feed rate is 0.2 mm per revolution. And what is the maximum depth of cut? D is equal to 2 mm. So he is asking us to calculate the tool approach, that is L1, and overall travel distance. So just try to listen carefully. Overall travel distance as 8 mm. Overall travel distance is given by capital L for the turning, for this particular turning operation. So you just try to see before commencing the problem, because here both the diameter of the job and length of the job will be reduced by turning. The diameter of the job will be reduced from 50 mm to somewhat final diameter df, and the length of the job, in what is the initial length of the job, Li. Here you can give as Li 170 mm, Lf is 165 mm. So just try to just go for the write down the given data as far the problem is concerned and proceed with the problem like this. So this is very important typical problem that can be asked in section B. So what is time for turning? What is the total length? So what is the total length he has given? So just try to see. Take tool approach and overall travel distance as 8 mm. So what is, you have to add that overall travel distance to the initial length of the job, that is 170. So we'll get the total length of tool travel. That is very important aspect you have to consider before calculate resuming with the machining time for turning. So what is the required depth of cut? Already I have told you what is the required depth of cut. Here he has given DI. What is DI? 50. DF is 40. Just try to go again the data. So you just try to 50 mm diameter and 40 mm diameter. So it is reduced, 50 mm diameter is reduced to 40. That 40 will be the final diameter of the job. So the required depth of cut is the half of the subtraction of the initial diameter minus the final diameter. So 50 minus 40 by 2. So depth of cut is given as 5 mm. But you just try to say what is the depth, what is the maximum depth of cut? He has given the problem. What is the maximum depth of cut he has given in the problem? He has given as 2 mm. So what is the number of cuts? So you, while calculating NP, the number of passes, the number of cuts will be NP is equal to the required depth of cut by the maximum depth of cut. What is NP? Here it is the required depth of cut is 5 mm. But what is the maximum depth of cut that is given in the problem? it is 5 by 2. It is 2.5. You cannot take as a 2.5. So you are approximating that number of passes as 3 instead of 2.5. So what is the total turning time or the machining time? Total turning time or the machining time is given by what? The machining time for one cut into number of cuts. So in this derivation we have done already. So NP is 3. So what is the machining time for one cut? Capital L by F into N. So here people will be confused because in the data he has given 170. They try to put 170, then you will get wrong answer. So you have to consider that particular 8 that is given in the data. That is the what is 8 here? It is the it is the try to speak because it is a one way. It will be you'll be in trouble. So what is in the data? What is 8? What is 8? He has given the overall travel distance at 8 mm for this one. Overall travel distance as 8 mm. So 170 plus 8. Suppose you are taking 170 in the final while calculating the machining time, you will get a wrong answer. So the total length of tool travel is the job length plus that plus 8, 178. So that is very important, and you have to take into consideration the machining time for one cut. Machining time for one cut. So L by Fn into Np. So that 178 by what is speed rate? 0.2. N is given as 400 RPM. Number of passes, number of cuts or number of cuts is given by 3. So this is the 6.6. So he has asked the particular time for separately. Here you have to calculate the machining time for turning as well as the machining time for facing operation. Well, because while turning the length you have to consider the particular diameter of the job for facing. The initial diameter of the job is di 500 mm and the final diameter of the job is df 400 mm. But before facing, the diameter of the job is already turned, because after turning only you go for facing, but before facing the diameter of the job is already turned to 400 diameter. But what you have to do here in order to calculate, already we have seen in the earlier problem for the facing problem, you have taken half of the diameter of the half of the diameter of the final diameter, half of the final diameter. So since in facing, what will be happening? The length of tool travel is equal to half of the job diameter. So what is half of the job diameter? Is the final diameter. So L is equal to 40 by 2. Here you have to take L as 20 mm. L as 20 mm. So what is the time required for facing one pass? L by Fn. So instead of that 178 you have taken in turning, already you have calculated for facing 40 by 2. You have to take that value. Don't confuse yourself, because this is a very important problem which so many people will try to commit mistakes, because here what they do, because some may take capital L as 50 minus 40 by 2. That's also wrong. That you are taking only for the depth of cut. Here you are taking the capital L as the length of tool travel. Length of tool travel. So what are the mistakes the students are committing? I'll prior information I'm giving. So L is 200. Feed rate is 0.2. So N is 400 mm. So time for one pass is 0.25 minutes. So how many passes are there? You have calculated. But here for turning you have calculated. But here from the fundamentals, what is the material removed? Di minus df by 2. Di minus df by 2 is the material removed, material to be removed, MRR by maximum depth of cut. So you have got that as 5 by 2. So maximum depth of cut is what is the required depth of cut? What is the required depth of cut is 5. So that you have taken as NP. You have calculated already. Here he is again calculating, but already I have calculated. You don't have to show, but you can show in this form also, because it is 50. You just try to substitute here also for facing from the fundamentals 50 minus 40 by 2. Same value you are getting, but sometimes you may get different values. But from the fundamentals again you have to calculate for the number of passes for facing. So it is 10 by 2, 5. The material to be removed is 5. Maximum depth of cut he has given in the problem. Yes, 2. And there is again 5 by 2, 2.5. So adjust that to 3. So what is the total machining time for facing? It is the time taken for one pass is 0.25 into 3. That is 0.75 minutes. 0.75 minutes. So what is the total time for machining? Total time for machining is the total turning time plus total facing time. Total time taken for turning plus total time taken for facing. 6.6 plus 0.75. 6.6 plus 0.75. So this is a typical problem. All of you practice. All of you practice at home, because if you are having that particular book, okay, I'll be sharing this, and slowly we have another 15 minutes time. Whatever problems we can do, 2 problems or 1 problem, we'll try to do, and slowly we are going to the last topic in this particular unit. What is the last topic? If you try to see tool layout, tool layout is the last topic, and he has given in the syllabus also the tool layout and cam design for the automats, that is the single spindle automats or the automatic machines or the multi spindle automats. We'll just try to have that. So in this somewhat you'll be learning the process sheet, whatever we are discussing before as far as the production drawing is concerned. So I may be asking the tool automat for hexagonal bolt or hexagonal job. We'll try to see later. Tomorrow and day after tomorrow we'll complete the syllabus. So I'll go for a new screen share. So just you try to bear with me. So try to note down this problem also. So what is the problem? Simple problem. Yesterday we have done this also. It's a problem related to the what? The tail stock set over method. Tail stock set over method. So he has given the shaft length as the length of the shaft L as 500 mm, the taper as 100 mm per meter for a distance of 200 mm from one end. Mind you, he has given only one distance from one end only. So the what is the maximum diameter of the shaft? He has given as 150 mm. 150 mm. So the distance from one end is only simply small l. You have to take the correct notations. So yesterday I already told you the notations and done one problem. So this is the second problem, the same problem, but it is a once he has asked in the examination, the final examination, JNTU Kakinada. So what is the maximum diameter of the shaft? What is the maximum diameter of the shaft? It is 150 mm. What is the taper? Already I told you how to calculate the taper yesterday. Taper is capital D minus small d by L into 1000 by into 1000. So you have to see this. You have to, what is the taper? You have to calculate, but he has given only the small d. The maximum diameter of the shaft, the big end diameter he has given. The small end diameter is not given. The small end diameter is not given in the problem. So first your attempt is you have to calculate the small end diameter, small d. So what is taper? Taper is given by capital D minus small d by L into 1000. This is the formula we have discussed yesterday. So you have to, what is the taper he has given in the problem? Taper of 100 mm per minute. So T instead of T, 100 is equal to, what is capital D? Maximum diameter of the shaft. Maximum diameter of the shaft. So big end diameter minus small end diameter, you have to calculate. So what is that small end diameter? You will be getting that as some 130, I think. So just try to see that you are well aware of the substitutions. You just try to practice this also at home. Don't all of you don't talk among yourselves. I've already unmuted, but again you are going for the. So just try to mute again. Don't unmute yourself. So you just try to see this. You have calculated the small end diameter, small d, that is 130 mm. So what is asked, you just try to see, and 130. So next, what he has asked, you just try to see amount of set over he has asked. So what is amount of set over? You just try to see in the last class. What is S? S is equal to capital L into D minus D by 2L. The L is the distance from one end he has given. Capital L is nothing but it is the length of the shaft, overall length of the shaft, and the distance from one end is small l. So you have to be familiar with the terms, and what is the length of the shaft is 500. Capital D already has given. The maximum diameter of the shaft is 150. The big end diameter of the major diameter only with screw threads we will try to use. Big end diameter, small d I have calculated 130, and what is capital S? Amount of set over required for the taper turning operation, that is here you have got as 25 mm. Capital S is equal to capital L into D minus D by 2L. Here people may commit mistakes if you are taking that as D minus D by only L, that is taper into 1000, that is only the taper in mm. Here people try to forget that numerical 2 here. So L into D minus D by 2L. That is very important. You have to see the amount of set over required is given by S. So this is one of the simple problems, but whatever you may given unit 1 or the set 1 or set 2, the first section or the second section, we cannot say. So you have to be familiar with A to Z topics in the unit, whether it's unit 1 to unit 2 or unit 3. And as far as your first internal it is concerned, unit 1, unit 2 and unit 3. So whatever syllabus will complete, maybe half up to the internal, it will be there up to the last day before the announcement of the first internal exam, because that is mandatory, that is given by the JNTU guidelines. And the quiz also, it will be covering all the 3 units. So try to be careful as far as preparation is concerned. So that is very important. So that is the first, that is a problem. And the next problem also we'll see. If we cannot complete, we'll try to continue in the next class, because 9 minutes are there for me as far as me is concerned, because only 3 hours are there today. So the next problem is related to the gears. Calculate the gears for cutting metric threads of the following pitches. So what is the pitch? 4 mm pitch he has given one, and one is the 4.25 pitch. So in the given problems, he is asking you, he is testing your knowledge on the lead screw of a lathe. So he has given as the lead screw of a lathe contains 6 threads per inch, 6 thread per inch. So just try to see. So that is the problem, and the lathe is supplied with 20 to 120 teeth. 20 to 120 teeth. That is a very important. 20 to 120 teeth in steps of 5. So just try to see that that is blocking the screen. In steps of 5 he has given, and an additional gear wheel of having, which is having a teeth of 120, 127. Additional gear wheel is having 127 teeth. So what he is asking us to calculate the gears, what are the set of gears you have to use for the driver and driven. You have to calculate for a pitch of 4 mm and for a pitch of 5.25 mm. First we will try to go for the first case. And what is the number of stars he has given? What do you mean by lead screw of the lathe contains 6 TPI? That is the number of starts he has given, because lead is NP. So number of starts he has given as 6 TPI. So for a pitch of 4 mm, lead is NP. N is the number of starts is 6 and pitch is 4 mm. So that is a lead. So you have to calculate. Yesterday I told you this formula, driver by driven. So what is the lead threads on the job or the workpiece by driven? What is driven? Lead of threads on the lead screw. So you have to calculate both this particular the ratio of driver by driven, and you will be getting that as 5 by 27 is common formula that is given, because in the formula itself he has given that you have to just remember or by heart 5 by 27 into NP. 5 by 127 into NP. NP is 6 into 4. What is the final result you will be getting? You just try to see. So the final result you will be getting as 5 into 6 into 4 is 120, the numerator, and by 127. So what is the meaning of this? The stud gear, that is the driver, contains 120 teeth, and the lead screw contains 127 teeth. Lead screw contains 127 teeth. That is how you have to depict, because this is only for the simple gate train, and this problem, the first case maybe it is for a simple gate train, and the second problem we'll just try to see whether it is for a simple gate train or a compound gate train, because you'll be learning that in theory of machines, that is in DOM now. DOM now, the gate trains, because it is all the subjects are equally important as for the machine design, thermal and manufacturing, because you are still in the undergraduate stage. Give equal importance to all the subjects. Time and again I'm telling you. So P is 5.25. What is lead? Because N is what is N? N number of starts. Lead is number of starts into pitch. Here the pitch for the second case he has given as 5.25. So what is driver by driven? Again, the conventional formula you try to take the fundamentals. Lead of threads on job by lead of threads on lead screw. So that is very important. You have to take into consideration. Again, that as 5 by 127. It is in the textbook. The formulas 5 by 127 into NP. NP is 6 into 5.25. So you just try to rewrite that 5.25 as 525 by 100. 525 by 100 simply in the next step. So it will be 5 by 127 into 6 into 525 by 100. So rearrange the terms, and 5 by 20. 5, you just try to strike out 5. Here will be 120. So it is 6 into the still, in spite of telling the people are just enjoying the quarantine, okay, but the internal and external you will be facing difficulty. So 6 into 525 by 127 into 20. So you rearrange the terms like this. So how to rearrange the terms? You have to see. Again, you can go for substitution of this one, 5 fours and 5 105s. That will be 6 into 105 by 127 into 4 into 10 by 10. Just you are writing, because there is there 10 by 10, by writing 10 by 10, this particular value will not change. Why? Because you are going for 105 into 60. 105 into 60 by 127 into 40. 127 into 40. By writing this, by rearranging the terms, you can easily understand the compound gate train is needed for the screw thread, for the screw threading cutting operation, in which the stud gear, you just try to see that the stud gear is having 125 teeth. Stud gear is having a 125 teeth. Here in between, because for a compound gear, we'll be having an intermediate gear. We'll be having an intermediate gear which is consisting of 127 teeth, 127 teeth, and here the driver gear. The driver gear is possessing 160 teeth, and the driven gear is consisting of 40 teeth. You have to explain. Don't simply leave the numericals there, because for this compound gate train is required for this particular pitch of 5.25. How you have calculated, you have seen, and that compound gate train is required, in which the stud gear is required, contains 105 teeth, and this is an intermediate gear which is connecting the stud gear with the driver gear and the driven gear. The driver gear is consisting of 60 teeth here and 40 teeth. That's why you try to multiply any problem related to some particular numerals other than 4 or 3 or 5 is giving this one in terms of 5.25 or 5.5 or 4.25 or 3.25, you can get you can observe by this experience that you have to use the compound gate ran for thread cutting operation on the lathe. That is simple as that. So this is a problem. Just right, I'll share both this particular problems on lathe machine. Yesterday we have done we have gone only for the derivations. Today we have done as many problems. Although that maybe simple problems are there. Some uh, some problems may be difficult to understand, but you try to concentrate. Even if I'm muting or unmuting yourselves and speaking, that is not good on your part, because every time we cannot teach moral science in engineering. We cannot teach the professional ethics are also there. That's on the subject, but you have to implement that in your daily life. In your daily life, you have to implement. You can because previously in the schools they used to teach moral science. So here you have to abide by the rules and regulations of online classes. Don't read. Okay. We'll just try to stop here, and tomorrow we'll join for the third hour, the tool layout or any other topic that is left behind. So we'll try to stop here. Thank you for the patient listening.